So, give you guys a little bit of understanding here about what we're going to do. Real quick, I'm just going to kind of ghetto graph this real fast, just so you guys can get an idea. So, -4, 5, -2, 3, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have a graph that looks like this, right? And it's asking us, and you don't need to write this. I just want you guys to watch. I'm just kind of front loading some information for you here. We want to do a right Riemann sum. Now we did that yesterday, so we know that usually what that means we're going to start on the right side. We're going to draw our little lengths here. We don't include the last one, right? And then we're going to drop down some bars after that, right? So nothing new so far. Okay, but each of these rectangles is what you could call a subinterval. The whole interval is something that goes from -4 all the way up to 12. So that's my interval I'm looking at. Now, within there I've got some subintervals, okay? Now each one of these intervals, it looks to me, are like 2 long. Does that make sense? From here to here is 2 spaces long, so on and so forth. Those are what we call subintervals. But look at the directions here. It says use a right-hand Riemann sum, but they only want 4 subintervals. Right now I have 8. I've got 8 subintervals. So I've broken up that distance from -4 to 12 into 2's, which gives me a total of 8 subintervals. Is that good? So we want 4 though. So in other words, I'm gonna want these things to be bigger. So let me show you what that would look like instead. So if I'm going from -4 to 12, what I want to see is, instead of seeing 8 rectangles, I only want to see, I don't know, maybe it'll look more like this. I only want to see 4 rectangles. Does that make sense? Okay, so that's the idea there. So now, why would they want to do that? Well, I don't know. Why not? You could do whatever you want technically. So, but I have seen that question pop up on AP exams. I know that one of your FRQs this week do that, so I want you guys to know how to do it. Okay, so how do you do this? First of all, in your notes, I would underline this, and I would put, that means we need 4 rectangles. I just want you guys to be connecting this to something that has meaning to us. When they say 4 subintervals, that means we want 4 rectangles. Okay? So, how do we make 4 equal subintervals? You might want to write this down. How do we make equal subintervals? Well, first of all, you want to figure out how big is your total interval from beginning to end. So what you're going to do is you're going to find out what's your last x value, and you're going to subtract from that your first x value, and that will tell you your total span, your total interval. Okay? Now, I want to break it up into 4 pieces, right? So after you subtract your last one from your first one, you're going to divide it by however many subintervals you want. And that's basically going to tell you how wide each rectangle is going to end up being. And I'll tell you why, but in a minute. We also call it delta x sometimes. You might already see why, but I'll show you why that is in a minute. So let's kind of revisit this problem here. So I want to break up this interval into 4 equal subintervals. Okay? So I take my last x value, which is what? And I subtract from that my first x value, which is? -4. And what? Which is 16. That basically tells me how big of an interval I'm looking at, right? And
4 with rectangles.
There you go. We want 4 equal subintervals, so I'm going to divide that total up into 4. And that tells me 4. But what does that 4 mean? That tells you how wide each rectangle is going to be. We're going to have 4 sets of 4. 4 groups of rectangles that have a width of 4 for a total of 16. Okay? Mm-hmm.
4, 4 to 8, 8 to 12.
Very good.
Effectively, the function exists at all those points in one part.
That's, yeah, so that it,
What's the point
when you're doing tables, yeah, it doesn't always work if they have to deliberately set the table up for that. So we want widths of 4, right? So if I start at 4, how far is that going to go to? 0. So I'm skipping 1 there. Will it always be skipping 1? No, it depends on how wide they want the interval to be. Since I want my intervals to be 4 spaces long, I'm going from -4 to 0. Sometimes you might find that it's just a normal one, depending on what they ask. Sometimes you'll skip 2. It just depends on what the width is. Now I'm going to go from 0 to what? And so on. And there it is. So now you guys can see yesterday when we did this, those were our rectangle widths, right? But hopefully you guys can also see why I'm calling it delta x. I don't think it really matters if you guys call it that or not, but I don't want to put that like it's a fraction. It's not. But delta x just means change in x. So I'm going from this x value to that x value, so that's my delta x, right? Okay, so now here's another tricky part. You got to visualize the rectangles for this. We need our heights too. You're not going to use every height in here, right? So first of all, we're doing a right-hand Riemann sum. So I'm going to start over here on this side. So do you guys see how these three numbers here are my last group, right? That's my last rectangle with a base of 4. Which of those numbers represents the height for a right Riemann sum? It's the 13. Remember, the y values are the height, right? And since this one is the one on the right, that's your height. Same thing for the next one. For the next one, what's the height going to be for this next group of, where was it, here? For this next group, what's the height? 9. How about for the next one? And then? There you go. So we have then 4, 20, 36, and 52, which if you add all those together, I believe we got 112 last block, but you can double check my math.
Do you write the table so it's not as messy and kind of easier to spot where the heights are?
You can. So like when you're doing a free response question, you gotta understand, like, they only give you 15 minutes for these things. So, you know, I think that at first, like for homework stuff, that might be a fine idea. But when you're actually taking your test, you might want to have gotten to a place where you can just work with what they give you so you can kind of keep up your pace. But yeah, you could definitely. I mean, I'm not going to say you can't do that. All right, so there it is. So let's review really quick. What was different about this problem? The fact that they tell us they only want a certain number of subintervals. How do you find how big those subintervals should be? Last x value minus first x value divided by how many chunks you want. We got 4. From there, that's how big you skip by, which tells you the width of each rectangle. And in this case, since it's a right Riemann sum, for each group of that chunk, I always use the one on the right for the height. Right? Now, if I was doing a left Riemann sum, what would be my first height? 5 would be. What would be the next one? 1, and so on. So, all right. So I'm going to let you guys practice one of these really quick, and then I'll put the homework up, and you guys can do that one last homework problem. There's even more problems on that worksheet that we didn't get to. Those ones are kind of like, I don't really care about those too much, so I'm going to leave those with you guys on sub day to mess around with. But this one is kind of important in the ones before, so that's why I wanted to be here for those. So go ahead and try that student practice and see what you get. Got to pay attention to what sum you're doing, of course. And I think this is supposed to say 3, by the way. So I'm going to change this 4 into a 3. There you go. So how wide is each rectangle, guys? 2. How do we know that? Because we take the last x value, we subtract from it the first x value, and we divide by how many intervals we want. And so 6 divided by 3 is 2, which tells us that up here we're counting by 2's. Like so. Okay? So now this is a left Riemann sum. So what's the first height? It's going to be 9. Good. What's the next height? The 6. And then the 15. So if you do 9 times 2, 6 times 2, and 15 times 2, and add all those up, you get 60, and that's your final answer. So that's it. Nothing special there. Just wanted to make sure you guys got to see that. And so the only one that we're going to add down to our homework is number 7. So I'm going to go ahead and put that up, and you guys can work on that, add it down now, or you can just save it for tonight for homework if you prefer that. Okay? So